The most difficult problem we have, the thing we haven't really resolved, is we have nail laminated timber decks. They're 3x4 laminates, and once they start to rot, there's not much you can do with them. So those are the bridges we're trying hard to replace. When I started, they said 39 and a half years ago, they told me not to worry about timber bridges because within 10 years they'd all be replaced. So we had about 120 of them then. We have close to 100 right now. So they're at this much longer. And then I asked Dwayne, who's our asset management engineer, how long before we replace these? And he said, Chris, do your best to maintain them as long as you can because there's no money. So piece by piece, as Travis kind of points out, you can replace them. So, and the crews like to do the work. It's kind of fun for them. They feel like they're doing lots of good stuff. So basically concrete decks are easier to maintain. We kind of like those. They kind of last a little longer, keep the water off, try to seal the joints in the decks, keep the water off again. And timber decks with bolting strips are better than nailing to stringers. Bolting strips require tightening as the deck ages, and timber decks need running boards or some kind of overlay, otherwise the timber just wears off. So overlays, another thing we found is a lot of these older timber bridges, they used to be on gravel roads, and when they came around to asphalt, they just asphalted over the gravel which was on the deck. And we found that that gravel layer kind of breaks so you don't have the timber coming through at the joints or over the caps, so that it looks pretty smooth as you're going across. But you find a lot of our maintenance people like to just keep putting asphalt on top. So we found when we went to load rate a lot of these bridges, some had 16, 18 inches of asphalt on. And they took care of that just by putting more curbing on them as you go up. So repairs, and I think Travis showed one of them was a split pile repair. I saw the guy, he was the whole pile up and down. This one just shows one. So right at the top where it was pulling apart. Cap repair. As first thing you have to do usually is get the load off the cap. We've tried all sorts of different ways. You can build temporary vents under the bridge to jack it up. This doesn't work well over water. It's difficult on slopes, difficult on high bridges. It's time consuming, and but it does have minimum traffic impact if you can do the lifting from underneath. Another thing we've tried are jacking beams on road decks, jacking blocks chained to piles, and jacking blocks clamped to piles. And what we finally ended up with are the jacking blocks clamped to piles. These were built in-house by our maintenance crew. They're aluminum. Thing is, you have to tighten up those bolts just like you tighten up the lug nuts on your car. You work your way around and kept getting it closer and closer. And unlike the ones you chain on, these things don't slip. They hold pretty tight, and you can lift the cap right off with these. Cap replacement is another one. You can replace a cap in kind. It's fairly low cost. It's difficult to obtain a permit for creosote-treated caps anymore. You can't find, you get new timber, not old-growth timber. It requires traffic control and usually temporary road closure, and usually requires a crane. One thing is if you do replace it with a treated timber, our crews usually put 14-inch wide roofing flashing on top to keep the water out. Keep the water off, it makes the caps last longer. You can replace with a steel beam, and Travis showed that. It's a longer lasting repair. May be difficult to match existing beam size. It costs more than replace in kind and requires traffic control and temporary road closure. Steel cladding, which as Travis admitted, they stole from us. So it's a longer lasting repair. It's more expensive than replace in kind. No crane is needed. Ours are made in 150-pound modular units, and there's no disposal cost for the creosote-treated timber that you've removed. Here's a picture of it, and besides the 150-pound units, they also put little grab things on, so you could easier to hold on to. The 150 is still pretty heavy for a couple of people trying to hold up in place. Here's a little closer look. And this is actually a job we did for City of Steilacoom. And the other thing we've done is, if you saw also on Travis's, depending upon where you jacking boxes, because you want to restore the load in the pile when you're done, and those little steel things way up on top, those are our jacking boxes. Very similar. We also weld in place once we put the load back in. This is a Michelle River Bridge. It was a bridge that was replaced with some steel girders that we happened to have on hand after a Loudon Arch washed out. Kind of a semi-temporary bridge. It had concrete abutment on one side, the steel girders, and then the intermediate pier was timber piles with all sorts of timber on it. It reached a point where we had about 20% of all the timber underneath was rotting, and the others were starting to rot. So we decided to lift the whole thing up, replaced everything with newer creosote-treated timber, put the load back on it. Within 6 months, the newer timbers had all squashed down. It had opened up the wood, and we were told we needed to replace all those, so we replaced them all with steel. What you see here is we had in the past been galvanizing everything to save money, because I figured the galvanizing is probably going to last 50, 60 years. I'm hoping we don't need these that long. So instead we just get buckets of the rhino liner stuff you use on the back of your pickup truck, and we just coat them with that, and it actually looks much closer to the creosote treated timbers that are there. So we have one truss left made of timber, kind of out in the middle of nowhere. And this one we had one of the truss legs was rotten, and so we had to take the load off. In this case, we used Bailey bridge parts, and we used those, take the load off the member that needed to be replaced. Here's the removal with a crane, and here's a section of it. You see it was pretty rotten. And here's the connection, bolting we used a square beam on this one, and some angles and clamps, and hooked it to some of the timber that was left. And there it is in place. And we painted it black so it matched the creosote. So we also replace piles with steel. In this case, we dig it out down a few feet, find good material, just like Travis in Oregon does. In this case, we just round formwork down into the hole. We put a lot of reinforcing in there. Pile goes right on top of the existing pile. Pour concrete in it, let it set for a while. We come back and see again we have one of those jacking boxes up on top. So we restore the load after the concrete has had time to set. Our latest, what we've been doing is just wrapping the pile and then pumping epoxy into the void. Here's a picture of the epoxy injection into the voids. What my crew told me is, in the very first one they didn't bring enough epoxy. So they pumped and they pumped and they pumped, and they used everything they had, came back and they pumped an equal amount, and they kept pumping. It was 3 times what they had anticipated would be needed. How do you replace a timber stringer? Do you ever try to do replace in kind, timber with timber? And usually you have to notch the timber stringer so you can slide it up, slip it back, and put it in place. It's much easier just to replace with steel. Put it up there in place, make sure it can carry the load, and you're good. What's more important, I think, is how do you prevent all this from happening? Since we're going to have to keep these things for 10, 20, 30, who knows how long, much longer. A good guide is the Guide for In-Place Treatment of Wood in Historic, Covered, and Modern Bridges. And that's a combination of USDA, U.S. Forest Service, and U.S. Highways. And there's a number on the thing, but you can just look it up. It's available online. It's got a lot of good, handy stuff, and it's like a cartoon. It's got a lot of pictures and diagrams and things. And they talk about pile preservation. You can use borate paste. You put it around it. You don't want the borate to go into the ground, so you have to wrap it in plastic, seal it up real good. so that the borate goes into the pile. In-place preservatives, they're diffusibles. These are water soluble. They diffuse 1 to 3 inches across the grain and 3 to 9 inches with the grain. They can come in powder, liquid, paste, and rods. Most common type is borate. EPA label is a caution for borate. Normal circumstances, these last up to 10 years in place. They're activated at the same wood moisture content as rot fungus. Not only do they kill the rot fungus, they kill termites and carpenter ants. So, all-purpose stuff. There's in-place preservatives. There's non-diffusibles, not as water soluble, used to treat surface damage to treated wood, useful in sealing bolt holes, used in timber construction, and copper naphthenate is a common non-diffusible. In-place preservation, or another one is fumigants. It's activated by moisture in the wood, but it diffuses as a gas. Because of that, it requires you that your checks and bolt holes be sealed. It can move several feet through the wood, kills rot fungus, termites, and carpenter ants. MITC is a common fumigant, and the EPA label for this is dangerous. So most states it requires a license to use that. Borate rods, this is what we've been using. It's a low-cost means to prevent rot by killing the fungus. It's in use by the log home industry, railroads, utility companies. Again, it's activated by 25% moisture content. Protection lasts about 10 years. Because of how they diffuse, usually insert the rods every 6 to 8 inches. And for quick activation, squirt liquid borate in the hole prior to inserting the rod. And don't use it for in-water piles because it'll just flush out. Here's an example of a supplemental treatment of a timber. This comes from that manual. Another picture, very similar. Here's one of the crew members down there drilling the holes, and before inserting the borate rods, just pop those things in place. Another thing that's important is track the usage. You know when the stuff was put in, so you can go check, see if the rods are still there, if you need to add more. You already got the holes. Initially, we just made our own plugs, but wherever you buy the borate rod, they have these little caps you can put on. You can just etch the date on the end of the cap, so you know about when you need to start checking. And that's it, and that's a picture of the one and only covered bridge in the state of Washington.
Thank you, Chris.
Okay.
Thank you, Travis. Thanks, Jason.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.